All right. So chapter 10, a reminder, chapter 10 has 2 problems. Same thing with chapter 11 also has 2 problems. So number 5 and number 6 will both be from chapter 10. So number 5, we want to find the center, the transverse axis, the vertices, the foci, and the asymptotes of the hyperbola. Then we want to graph the equation. For the sake of our review and the fact that we will be finding all of these values, when we go to graph our equation, we will just graph it in Desmos and take a look and make sure that everything checks out and everything is okay. So starting with this problem, we know that it is going to be a hyperbola stated to us in the problem, and we know that we need to find center, transverse axis, vertices, foci, and our asymptotes. So if we have this equation, x squared minus 49y squared is equal to 49, first thing we want to do is we want to put this in proper form. And we do this by dividing each term by 49. So x squared minus 49y squared is equal to 49 is now going to become x squared over 49 minus y squared over 1 is equal to 1. So we just wanted to put it in our proper form. And now that we have this, we can identify that this is of the form x squared over a minus y squared over b is equal to 1, since we see that 49 is greater than 1. So this is a squared, b squared, we forgot about that. So our a squared in this case is 49, our b squared is 1. We know that 49 has to be a since it is greater, and a is greater than b within our stated theorem. So we have our equation in this form. Knowing that our equation in this form, this means that our center is at the origin, which is 0, 0. This is because we see that our x squared and y squared, there's no number being added or subtracted to x or y in this case, which means that our center is at the origin. And the transverse axis in this case is going to be along whichever term is the numerator of a. So in this case, we have x squared divided by a squared. So our transverse axis is along the x-axis. If we had y squared divided by a squared, we know that our transverse axis would follow along the y-axis in that case. So it's whatever term, whatever either x or y term is in the numerator of your a squared value. So whichever is larger. So this is part of our answer. Our center is at the origin. The transverse axis is along the x-axis. We'll just highlight all of it. There we go. So that's one of our answers. So go ahead and check that off since there were quite a few things. Let's see, we found the center, we found the transverse axis. Now we want to find vertices, foci, and asymptotes. Then we have that a squared is equal to 49. Which means that a is equal to 7. We also have that b squared is equal to 1, which means that b is equal to 1. So we found our a squared and we found our b squared, which gave us our values of a and b. Then we know that the vertices are going to be at plus or minus a, 0, plus or minus a in the x value spot, since our transverse axis is along the x-axis. If it were along the y-axis, remember our vertices would be found at 0, comma, plus or minus a, so we would switch them for the different axes. But our vertices are going to be at plus or minus a, comma, 0. We know that a is 7, so this means that our vertices are going to be at negative 7, comma, 0 and 7, comma, 0. So we found our vertices. Then we also know that the foci are at plus or minus c, comma, 0, where we find c by using the Pythagorean theorem. So we need to find c. We get that c squared are equal to a squared plus b squared, which means that we get c squared is equal to 49 plus 1. So c squared is equal to 50, which if we take the square root of 50, gives us that c is going to be equal to 5 times the square root of 2, which is the same thing as the square root of 50. Since we see that when we have the square root of 50, this is equal to the square root of 25 times 2, we can then take out the 25, since 25 is 5 times 5, so we're left with 5 times the square root of 2. So we found our c, which means that the foci are going to be at negative 5 square root 2, comma, 0, and positive 5 square root 2, comma, 0. A small side note, 5 times the square root of 2 is going to be equal to about 7.071. So just a side note. So we found our vertices, we found our foci, transverse axis, center. The last thing that we need to find is our asymptotes. So our formulas and our equations, which are given to us in the section for which we worked on these kinds of problems, we get that we have 2 oblique asymptotes, which are found at y is equal to plus or minus b over a times x. And it's b over a times x when we're transversal along the x-axis. When we're transversal along the y-axis, we have a over b, so remember that distinction. We know the values of b, and we know the values of a, which means that our asymptotes are going to be y is equal to negative 1 over 7x and positive 1 over 7x. So we found everything our question asked us to find. We found the center, we found the vertices, we found the foci, and we found the asymptotes. So everything we found is going to now lead us to our graph of this hyperbola. So let's head on over to Desmos, where we can now see this hyperbola graphed, and we can just make sure that everything is correct. All right, so here we are in Desmos. We have our function graphed. We have our x squared over 49 minus y squared over 1 is equal to 1. We see we have our 2 branches here, and we can start making sure that we label everything. So our vertices we know are at negative 7, 0, and 7, 0. So when we label these, we see that they do land right there on our vertices. So right at the top, or right at the edges of these branches. Our foci, we know, are found at -5 times the square root of 2 comma 0 and 5 times the square root of 2 comma 0. So we can label these as well. And we see these points come up. This far away, they look like they're the exact same point. But what we can do is we can zoom in. Let's pick foci and vertices 1. And we can zoom in here and just make sure that they're not the exact same values. So we see our vertices here. This is at -7. And we know that our foci 1, which is going to be -5 times the square root of 2 comma 0, we know that's going to be about -7.07. So they're very close together. Let's go ahead and zoom back out so you can have a better look. So we've determined our vertices and our foci. Our center is at 0, 0 there. And lastly, we just want to mark our asymptotes. So our asymptote y is equal to 1/7x. Put that on there. We see that our branches follow along very nicely with our asymptotes, not touching, but following along infinitely. And the same thing with our asymptote of y is equal to -1/7 times x. So we see we have our two asymptotes here, and our function is within these asymptotes. We can even zoom out more or zoom in more. We can play around with Desmos quite a bit to get some interesting looks at our hyperbola, but we see that everything about our solutions would end up being correct since we ended with this image. So all right, let's head on back over to our review. All right, so we see that we successfully found all the correct points of a hyperbola. We found all the important parts, which were the center, transverse axis, vertices, foci, and asymptotes. And then we went ahead and just verified all of these answers by graphing on Desmos instead of looking at my poorly drawn graphs. So, all right, let's move on to number 6. So for number 6, we want to graph the curve whose parametric equations are given and shown and show its orientation. Then we want to find the rectangular equation of the curve. So we're given our parametric equations here. X is equal to 3t plus 4, y is equal to t plus 4, and t is found between 0 and 4. So something we can state here is that for each integer value of t, so integer values, these are going to be 0, 1, 2, 3, 4. For each integer value of t, we can find corresponding values of x and y to plot points so we can make a chart. So previously when we did problems like these, we have gone ahead and made a table and filled in all the values. We also just wanted to find the rectangular equations and then try to recognize a specific shape. In the case of this problem, since our interval is pretty short and our equations are pretty simple, something like this, it is going to be easier to just write out a table. So let's go ahead and write in a table here. So all right, we have our table here. We have our different values of t. Now we want to find our x and y values that correspond to specific values of t and then state our ordered pair. So if we want to find the value of x when t is equal to 0, we have 3 times 0, which is 0, plus 4. This is going to give us a value of 4. Then for y is equal to t plus 4, if t is equal to 0, then we have 0 plus 4, and y is equal to 4. This means our ordered pair is going to be at 4, 4. So our next value, t equals 1, 3 times 1 is 3, plus 4 is going to be 7. Then we have y is equal to t plus 4. 1 plus 4 is going to be equal to 5. So our ordered pair is 7, 5. Then for t equals 2, 3 times 2 is 6, plus 4 is 10. T plus 4 is 2 plus 4, which is 6, which means that we have our next point, which is at 10, 6. Then we have t equals 3, so 3 times 3 is 9, plus 4 is 13. Then y is equal to 3 plus 4, that's 3 plus 4, which is equal to 7. So we have 13, 7. Then our last value, t is equal to 4. 3 times 4 is going to be 12, plus 4 is 16, and 4 plus 4 is 8. So we get our last ordered pair at 16, 8. So our ordered pairs here are going to be useful when we go to graph. So let's go ahead and graph our ordered pairs. So we want to start with the ordered pair that corresponds to t's lowest value. So we go in order from 0 to 4. So plotting our first point is going to be at 4, 4. So our point's right there. Then our next value is going to be at 7, 5, which is going to be about right here. Then our point 10, 6 is going to be right here. 13, 7 is going to be about right there. And lastly, 16, 8. So we have our points, and now we can also connect them in order. So starting from our first ordered point, we connect all of our dots in order. We pretend that that's straight. And now what we do is we draw in our arrows signifying the direction that we went in. We can also label our ordered pairs if we would like. We know that this is at 4, 4. This one's at 7, 5, 10, 6, 13, 7, and 16, 8. So the curve, which in this case looks more like a straight line, whose parametric equations are given, would end up looking like this when we graph it. And we did this by solving for the values of x and y that are corresponding to specific ordered pairs, and then plotting those ordered pairs and keeping in mind the direction in which we are connecting our points. Now the second part of this equation, this question, is that we want to find the rectangular equation of the curve. So we did the first part, and now we want to do the second. So we can say that now we can find the rectangular equation of the curve we start by solving for t. In one of our parametric equations. Looking at our parametric equations, we have x is equal to 3t plus 4 and y is equal to t plus 4. The easier equation to solve for in this case is going to be y. So we'll solve for t in our equation for y. Again, equation of x and y. Okay, good. So we get y is equal to t plus 4. Solving this in terms of t, we now get t. We're solving this for t, so it's now in terms of y. We get t is equal to y minus 4. So now we can just plug this in for our equation x. So we can plug in y minus 4 in our equation. X is equal to 3t plus 4. So if we have x is equal to 3t plus 4, we can now get x is equal to 3 times y minus 4 plus 4. Simplifying this equation, this turns into 3y minus 12 plus 4, which is going to end up giving us x is equal to 3y minus 8. And that would end up being our rectangular equation. All we needed to do for our rectangular equation was have everything in terms of x and y. We don't have to have it as x equals or y equals. We can have it be either. So since we've solved for x is equal to 3y minus 8, that just means that this is our rectangular equation. So thus, the rectangular equation is x is equal to 3y minus 8. You could also solve this for y. Your answer would still be correct if you solved it for y. If you did solve it for y, in this case, it would end up being y is equal to 1/3 x minus 8 over 3. So definitely not as nice looking as if we use x is equal to 3y minus 8, but also correct as well. So definitely a few bits that we had to work on. We had to go through actually graphing these parametric equations for the specified interval, but then going ahead and turning these into rectangular equations.